Hey everyone, and welcome. If you're studying pharmacy, you're in exactly the right place. Today, we're diving into a piece of equipment that's absolutely fundamental, something you'll definitely see in your labs and your future career, the steam-jacketed kettle. So, here's our game plan for this explainer. First, we're going to look at the why, the problem this kettle was built to solve. Then we'll get into the cool science that makes it work, take it apart piece by piece, and then walk through a full cycle of how it operates. And to wrap it all up, we'll look at where it really shines in the world of pharmacy and what its limitations are. All right, let's get right into it. To really appreciate this machine, you first have to understand the classic challenge it was designed to overcome. So here's the big question. Imagine you have a delicate, valuable medicinal liquid. You need to remove some of the water to make it more concentrated, but if you just stick it over a direct flame, well, you get hot spots. It's going to burn, it's going to scorch, and you've just ruined your entire batch. So how do you heat it perfectly evenly?
The solution is actually really elegant, and it relies on two basic principles of physics that you already know: conduction and convection. This is the secret sauce behind the whole operation.
The kettle uses something called indirect heating. Now, the best way to picture this is to think of a double boiler in your kitchen, but on a much bigger industrial scale. Instead of putting a pan right on the fire, we're surrounding our main pan with an outer shell, a jacket, and we fill that jacket with steam.
And here's where that two-step process comes into play. First, the heat from the steam conducts through the metal wall of the inner pan. Then, that heat warms up the liquid inside, which starts to create these gentle, swirling convection currents. That constant movement is what distributes the heat so beautifully, getting rid of those nasty hot spots for good.
Okay, so we've got the principle down. Now, let's actually deconstruct this thing and look at the anatomy of the kettle itself. Let's see what all the parts are and what they do.
You can see how each part here has a super specific job. You've got the inner pan, that's where your product goes. The outer steam jacket is the engine room where the steam does its work. You need a steam inlet and outlet to keep that steam flowing. And see those things called trunnions? Those are basically heavy-duty pivots that let you tilt the entire kettle to pour everything out when you're done. It's a really smart, simple design.
So, let's put it all together now. We know the principle, we know the parts. Let's walk through how you'd actually use one of these from start to finish.
And here's the whole process, nice and simple. First, you load your liquid, or feed, into that inner pan. Then, you introduce steam into the jacket. That's when the heating starts. As the heat transfers, the solvent, usually water, begins to evaporate. As more and more solvent leaves, your product gets more and more concentrated. And finally, once it's ready, you just tilt the whole kettle on those trunnions and discharge your finished product. It's a beautiful, controlled batch process.
Okay, that covers the how. Now for the practical stuff. Where are you actually going to see this thing in the real world? What is it good at? And where does it fall short?
You'll find its uses are pretty widespread. It's a go-to for concentrating things like water-based herbal extracts, and it's perfect for making syrups. Think about simple syrup or the base for cough syrups. Basically, anytime you need to gently evaporate a solvent for a gallonical preparation, this kettle is a workhorse. You'll find it in both small labs and larger manufacturing sites.
But, no piece of equipment is perfect for everything. So let's talk about the trade-offs. The big advantages: it's simple, it's pretty cheap, and it's easy to run and to clean. And of course, its #1 pro is that uniform, gentle heating. The disadvantages? Well, it's a batch process, which means you do one load at a time. It's not continuous, so it can be slow. The heat transfer isn't super efficient, so it's not great for massive scale production, and probably not the best choice for materials that are extremely sensitive to heat.
So if you only remember one thing from all this, let it be this: the steam-jacketed kettle is your foundational tool for uniform, gentle heating. It cleverly uses steam indirectly to concentrate a product without destroying it. That's its whole purpose.
And I'll leave you with a final thought to connect this to your other studies. We know this is a batch process. So as you think about large-scale manufacturing, what problems does that create? And what kind of equipment do you think engineers have invented to move from making one batch at a time to a continuous, non-stop flow? Keep that in mind as you continue your journey. Thanks so much for joining this explainer.